Today, it's time to take a journey together to our planet's neighbor, Andromeda. Every single point you see here is a massive star, visible even from a distance of 2.5 million light-years, and each of them most likely has its own planets, comets, asteroids, in other words, its own story. The Hubble Space Telescope has created the most comprehensive and deepest image of the Andromeda Galaxy ever made, and we are now seeing it in a completely different light. It is so bright, so dazzling, that as you move closer to the galaxy's center, the stars become so densely packed that they begin to look like a single solid sphere made of pure golden light. This is not a graceful spiral gently drifting across the night sky. There is violence within Andromeda. It has a past and a future capable of producing devastating consequences for everything around it, including us. Welcome to the channel, dear friends. Our channel is still very new, but even at this stage, I want to thank you all sincerely for the incredible interest and support you've shown. And if you're just starting to watch us with this video, I also recommend checking out our other videos. Subscribe to the channel, turn on notifications, and become part of that core audience that was here from the very beginning. Thank you all so much in advance. Now, if you like, let's dive into the details. We will examine the most impressive image of Andromeda ever taken, together with the 200 million stars it contains. Yes, you heard that right, 200 million stars, an incredible number. We will see how this groundbreaking Hubble portrait is used to reconstruct Andromeda's turbulent past and to predict what kind of cosmic violence may await it in the future. We have been observing Andromeda for more than 1,000 years. In fact, the first recorded observation dates back to the year 964, made by the Persian astronomer Abd al-Rahman al-Sufi. He described what he saw as a blurry patch of light, and it would take nearly 700 more years before we could obtain a clearer image. On December 15, 1612, Simon Marius became the first person to observe the Andromeda Galaxy with a telescope. Slowly, the details hidden behind this misty nebula began to emerge. In 1764, Charles Messier officially classified it as M31, but the real turning point came about 100 years later. An Irish nobleman and eccentric amateur astronomer, William Parsons, built a gigantic telescope in the garden of Birr Castle. This 72-inch telescope remained the largest in the world for nearly 70 years. Using this astronomical monster, Parsons discovered the spiral structure of M51, the galaxy we now know as the Whirlpool Galaxy. This was the first time a spiral structure had ever been observed in a nebula and sparked a revolution in the world of astronomy. Other fuzzy objects in the sky soon came under close examination. As a result of this wave of interest, in 1885, English amateur astronomer Isaac Roberts took the first photograph of Andromeda, and the image clearly revealed its spiral structure. Despite all this evidence, scientists were still unsure what Andromeda actually was. They classified it as part of a large group called spiral nebulae. The most striking common feature of these objects was that they did not move across the night sky like stars. This realization led to one of the greatest debates of 19th century astronomy. Were these spiral nebulae inside the Milky Way, or could there be other island universes beyond it? The answer came in 1925. Edwin Hubble detected two Cepheid variable stars in Andromeda. These special stars are standard candles, used to measure distances to faraway galaxies thanks to the relationship between their brightness and their periods. Hubble calculated that these stars were about 1 million light-years away. This distance was far beyond the accepted diameter of the Milky Way at the time, which was believed to be only 300,000 light-years. With a single calculation using a single type of star, the universe suddenly became far larger than anyone had imagined. Even today, these distances are extremely difficult to comprehend. At that time, they must have felt like something out of a dream. Since Hubble's discovery that the universe extends beyond the Milky Way, we have discovered countless galaxies. But our connection with that special neighbor that first opened our eyes to the true scale of the cosmos, Andromeda, has always been different. In some ways, Andromeda has taught us more about our own galaxy than the Milky Way itself. Studying the Milky Way is difficult because we are inside it. Dense stars, gas clouds, dust lanes, interstellar dust that scatters light and makes everything appear redder than actual, complex light patterns that complicate distance measurements, and foreground noise that sometimes hides details entirely. All of these stand in our way. Andromeda, on the other hand, does not suffer from most of these problems. Because it lies about 2.5 million light-years away, Andromeda acts like a cosmic laboratory, allowing us to study how a galaxy forms, evolves, and changes with relatively few obstacles. Still, to get the most out of this laboratory, we need images of extraordinary clarity. Experts and amateurs alike have studied Andromeda for decades using ground-based telescopes and space telescopes, observing it from different angles, at different resolutions, and at different wavelengths. But on January 16, 2025, the Hubble Space Telescope released an image that made all previous studies seem almost insignificant. After 10 years of careful observation, Hubble completed the largest photo mosaic ever created. More than 1,000 Hubble orbits, over 600 frames, and a total of 2.5 billion pixels. What emerged was the deepest and most complete image of Andromeda ever seen. If you're ready, let's take a closer look.
In this image, we see Andromeda at an inclination of nearly edge-on, tilted about 77 degrees relative to Earth. The northern region lies on the right side, while the southern region is on the left. Astronomers believe that Andromeda may contain up to 1 trillion stars. Yes, let me repeat that. It is thought that Andromeda may host up to 1 trillion stars. However, most of these stars are too faint to be detected even by a powerful telescope like Hubble. Still, Hubble managed to resolve 200 million individual stars. This makes it the most detailed image ever taken of any galaxy. Thanks to this enormous dataset, scientists can now extract information about Andromeda's past, its similarities and differences with our own galaxy, and how it may evolve in the future with an unprecedented level of clarity. Based on what we know, Andromeda is a spiral galaxy about 150,000 light-years wide. Its arms extend outward from the core. But although it is classified as a spiral galaxy, many of its features are surprisingly unusual, and thanks to this new image, we are beginning to understand why. This mosaic image first emerged in 2015 when the PHAT program, the Panchromatic Andromeda Treasury, was completed. Even back then, it was extremely detailed because Hubble spent more than 3 years photographing 1/3 of Andromeda's star-forming disk. The images were captured in 6 different spectral bands, ranging from near ultraviolet to near infrared. When you look at the outer regions, you see an elliptical ring of star formation located about 10 kiloparsecs from Andromeda's core. The young stars born in this region are bluer, meaning hotter than others. They are also metal-rich, containing elements heavier than hydrogen and helium. As you zoom in, even more details appear. According to the Hubble team, the stars resemble grains of sand scattered across a beach. This ring puzzled astronomers for a long time, but it was not the only anomaly. In 2006, images taken by the Spitzer Space Telescope's infrared array camera revealed a second inner dust ring located about half a kiloparsec from Andromeda's center. Interestingly, this ring had been right in front of us for years. We had simply mistaken it for something else. Scientists initially interpreted it as a small spiral structure formed by overlapping stellar orbits. So where did these rings come from? The presence of 2 separate rings showed that what we were seeing was not a coincidence. The origin of these rings was like a key that could unlock Andromeda's past. For many years, when scientists looked into Andromeda's history, they found no clear evidence of extreme violence or a major catastrophe. The galaxy appeared relatively calm. But these rings tell a very different story. David Block, the lead author of the 2006 study, described the dust rings like this. These rings are like ripples created when a stone is thrown into a pond. So where do the ripples come from? From an impact. The conclusion reached by scientists was clear. These rings were the remnants of a collision between Andromeda and one of its satellite galaxies about 210 million years ago. Just like a stone falling into water, another galaxy struck Andromeda's disk, sending waves of dust across the galaxy and leaving behind the two ghostly traces we still observe today. Bloch's team identified M32 as the likely culprit. Today, M32 appears near Andromeda's center, about 5 kiloparsecs away, looking nothing more than a blurry, bright knot of stars. When scientists turned to numerical simulations, essentially a digital time machine, and rewound the collision, they discovered that a direct, head-on impact reproduced the rings we see today almost perfectly. This was extraordinary. Even a strange gap in the outer ring, where it intersects with one of the spiral arms, appeared in the simulations exactly as it does in reality. But the story we thought had ended in 2006 was reopened by Hubble. For a long time, we believed this discovery had completed Andromeda's trauma file. But Hubble's new data show that only part of Andromeda's hidden past has been revealed. The massive Andromeda mosaic published in 2025 was not only the result of the PHAT program, but also of an extended project known as PHEST. This new program imaged Andromeda's southern region and added 90 million new stars to the stellar census. In addition, the scope of the study was expanded to include 2/3 of the galaxy's star-forming disk. Why was such an expansion necessary? Because scientists realized something crucial. Andromeda's northern and southern regions look almost nothing alike. This asymmetry tells a new story. And that story suggests that Andromeda's past collisions may be far more complex and far older than we previously thought. When we look at Andromeda's southern region, we see a structure that is far more disturbed and scarred compared to the north. The traces of Andromeda's violent past are concentrated here. Some of these traces are truly enormous. Although it cannot be fully resolved in the Hubble image, the giant southern stream located in Andromeda's southern region stretches across nearly 150 kiloparsecs. It is an immense flow of stars. You can think of it as a massive river of debris left behind by a galaxy whose stars were stripped away by Andromeda's gravity. The stars within this structure are cold, contain no gas, and do not collide with one another. Still, they are guided by Andromeda's immense gravitational pull, moving like marbles sliding along frictionless tracks. The giant southern stream, M32, and Andromeda's inner halo are among the most metal-rich regions of the galaxy. According to some astronomers, this shared characteristic is no coincidence. They may all be remnants of the same collision. And this collision may have been even larger than the event that created the famous ring structures. Interestingly, the main suspect behind this massive collision once again points to a familiar enemy. A study published in 2018 investigated this earlier and more significant merger and suggested that the culprit was the ancestor of M32, known as M32P. This ancient galaxy was once a metal-rich giant with a mass of about 25 billion suns. It is thought to have merged with Andromeda between 2 and 5 billion years ago. During the merger, M32P's gas was completely stripped away by Andromeda, triggering an enormous burst of star formation, effectively setting the galaxy ablaze. So much so that about 1/5 of the stars we see in Andromeda today are believed to have formed during this event. We even have stars that support this story. Astronomers have long been puzzled by a population of intermediate-aged stars, a few billion years old, found in Andromeda. Based on the Milky Way, such a distribution was not expected. But if these stars formed during the M32P merger, Andromeda's mysterious second youth suddenly makes sense. When we look at Andromeda in Hubble's new image, this theory becomes even stronger. What we are seeing is likely the stripped core of M32, and this description fits remarkably well. At the center of M32 lies a black hole with a mass of only 1.8 to 5 million suns. This suggests that the galaxy did not possess a large central bulge before the merger. As a result, instead of being completely absorbed by Andromeda, its core may have survived, been stripped away, and flung into its current orbit.
Of course, this is still a theory, but it brings together many of the mysteries of Andromeda's past into a single coherent scenario. It explains the rings, the giant southern stream, and many other strange features at once. Still, the story may be even more complex. There are 36 known dwarf galaxies surrounding Andromeda, and only recently have we begun to untangle how each of them may have interacted with it in the past. Thanks to Hubble's extraordinary resolution, we can now trace even the faintest clues. Perhaps we are only at the beginning. What else might Andromeda whisper from its past? Andromeda will collide with the Milky Way? But this story is not only about the past. This magnificent image also offers clues about the future, our future. As the two largest gravitational members of the local group, Andromeda and the Milky Way have long been considered the main actors in a potential collision. According to calculations made in 2017, Andromeda is approaching us at a speed of 110 kilometers per second, and there is a possibility of a collision in about 4 billion years. Of course, this is a scenario humanity will never have to experience, but imagining how two beloved galaxies might transform is still fascinating, like a movie. However, before we start dreaming of Milkomeda, there's a small detail. This collision is not certain. Hubble's new image has shaken things up. In a study published this year, Tasala and his team from the University of Helsinki recalibrated local group models using PHAT data from Andromeda. In particular, the PHAT program's measurements of 55 Cepheid variable stars in Andromeda, when combined with the orbital data of other local group galaxies, such as the Large Magellanic Cloud, produced an interesting result. The fate of the Milky Way may not be as dark as we once thought. Within the next 10 billion years, the probability of a merger with Andromeda is only 50%. The possibility still exists, but it is not certain, and most likely we will never see it. Predicting what will happen in our galactic neighborhood billions of years from now is not easy, but with an image this detailed in our hands today, modeling the future has become far more possible. And this brings us to a fundamental question: where are we going? The 10-year efforts behind the PHAT and PHEST programs have come to an end, but the story does not stop here. This single image contains enough detail to fill 75 ultra-high-resolution 8K screens. Scientists have only uncovered a fraction of the secrets hidden within it, and this is just one piece of the puzzle. Even though Hubble has turned its gaze to other targets, in June of this year, the Chandra X-ray Observatory captured the most detailed images ever taken of Andromeda's supermassive black hole. Each new observation adds another layer to the story of our galactic